Alright, what's up? So, welcome to another video. It's me, Yui, and today in today's videos, we are gonna create a process monitor from scratch in C. If you guys don't have any idea about a process monitor, it's like if you use Windows, it's kind of like window manager. The things like the program that you use to like track what is happening on your PC, like what is the process that is currently running, like Discord, Firefox, and it's gonna show you the memories and the RAM usage of that. Um, just let me close this before still session. That's Tidra. Um, so yeah, let me show you. We in Linux we have PS, which is roughly doing the normal PS commands. Gonna show what is currently processing, like running in this pseudo terminal. You can see TTY. If I do a PS, that's A, or maybe a PS that AUX is gonna be listing all of this. It's like all of the process currently running in your PC, and like, yeah, I can run Hatop. It's also the same thing that is currently showing you this, right? There's all of the process currently running, like Firefox. We have all sort of things, and in today's videos we're gonna build that. Just a simple versions of it, but yeah, we're gonna make that. And before going over it, I'm just gonna explain what I'm gonna do. And param in C, this kind of, so um just get to know how this kind of program gonna work. We can also use a top. A top is kind of like a top. A top is better. It's have color and stuff, but yeah, it's the same thing. You can see Discord, Bluetooth, it's running Sway. My window manager, I use Arch, by the way. So yes, do you know how this runs? Basically, they having this that it's reading the virtual file from the Linux kernel. So how this run is that so everything in Linux is a file that is it's Linux follow a Unix file philosophy. So that's why um, if we doing ls dash, or I can go cd here, even cd here, it's like all of the system, my disk and everything's mounted in here. So if I do a cd prot, so prot is the virtual things that Linux provide us. Let's do a man prot so you can see. So the prot is the file system that this is a pseudo file system, as I mentioned, and it's used to provide an interface of the kernel structure. So what the kernel do is kind of manage the hardware, and it's gonna like provide the pseudo file system. So we as user, we can see, we can monitor all of the things that is like not monitor, but like we can like just look at it, what is currently happening in our PC. So if I do ls/prot enter, this is all of the process that's currently running out in my PC. So each number, it's a file directory that is a process running. So if I go to do ls, let's try ls/prot /ones. So here we can see there's a lot of information of this process, right? So let's try to access stat. So let's do like this. Loki, it's a file, so we can print it. Slash proc slash one slash stat. So what is it? This is the process ID. It's the first one. There's like 1,000 of it in here. And this is system D, and all of this is the further information like the uptime and stuff like that. All right. So yeah, it's as I go over the codes, I think we will like get more idea about what am I doing. But just basically, I will be building a process monitor, just like top, just like this. But it's way simpler. It's way simpler. Okay, so um, now let's go to my projects directory, and we're gonna make this and call it a Minitop because it says a symbol up top, right? So now we're gonna make a make file so we can like kind of settings what we want our compiler to compile, and some easier make file. So this is what I want to add. So first we want a compiler, right? So our compiler, you can either use ClangB, but I would rather use GCC for my compiler. And we want to raise the flags for we want to have a flag settings for our program. So I just gonna call this warning. I just gonna enable all of the warning and even extra warning. So extra warning for our applications, and let's dash G. So yeah. So now what we want to do is we want to set the source, like the source that is access our main uh our main file, right? main.c, and also set what is like the name that we want our program to be compiled to. So let's dash so2 here. So we want our source src will be this src dash main c. Later on we're gonna create a c directory and the main file in here. Now we want our bin, our bin gonna be Minitop as the name of our programs. And so then we want to set all this into bins, right? This just basically mean that all of our file gonna be like compiled into just Minitop, just bins. And so now we're gonna add bins that's gonna kind of depends on this. I just kind of missed this. So here we want our source, right? So this means that for our program we need our main file. So then we're just gonna call our compiler to we're gonna raise our flag, just the C flags, just like that, and then that's all, right? And we want to target our Minitop, right? Then all of our dependencies, here. Oh, sorry, this one. Yeah, and we have our clean that is gonna clean our file. So remove our Minitop, right? Which is bins. If we do that correctly, I just want to double check if everything is good. Yeah, pretty sure everything is kind of defined. If I don't know if there's an error, but um I don't think if we really need this, right? I don't know, but yeah, this is seem pretty good. Uh, see if we have any further error. Yes, this is pretty good now. So now, let's head to. Oh, oh, I just forgot to move to our project. So let's move this net file into our Minitop. All right. So let's go into it. So now I'm gonna create a short. Now let's do just vim short dash man.c. Okay. I'll be here. Let's split that. Stupid. Let's make a directory sort and let's cd into sort and let's do vim man.c. So if now I'm gonna create a man functions, so make this bigger. A just return 0 and we can print something like easy. Let's just print hello world. Alright, let's print this. Our printf, we don't have it. Let's do what's the library? Let's search for it. Not pretty sure. Library? I think this like existed, right? Let's do them. Is it includes? Let's try. Standard IO, pretty sure. And let's run our make file. Let's cd and let's make. Low key, we don't really need our make file for now. I'm just messing up. Let's cd sort and let's just run this manually. Should we? Let's do cd. Target time. No, stop. Like that. Thing wrong here. Are there anything wrong here, bro? Source man.c. It's gonna Minitop. It's gonna be a bin and a source and a source. Yes, I messed this up too. We don't really need this. We don't have that semicolons. What is that? Alright. So now we have Minitop. Let's run it. Minitop. So yeah. Sorry, I was coughing. Yeah, it's print hello world. Alright, this is nice. This is so nice. We can run make clean. So now we can see our Minitop has gone, right? This is cool. So yeah, let's go vim short. No, let's go ft. So now I'll be creating a UI, right? We need a UI like kind of a UI that running when we run the functions. When we run the like our program, there would be like a UI that run. So yeah, let's see. For a UI, we can have like a while loop, right? And so let's have a while loop of once here. right, so I have preparing these documents that in our UI we want to hide our cursor, which is this one. So let's copy this. Just copy this. Alright. So let's print this. Alright. Let's copy copy this. Let's copy that. Okay, so what we want to do next, we're gonna print something like, so we hide our cursor like the UI, right? The thing is that we are not gonna block our standard app in, which just mean our like typing in the terminal, like our input to the terminal. We're not gonna block that, but we're gonna like refreshing this. We're gonna always refreshing it. So that's why we want to move our cursor always. We want like for each loop, we want to move our cursor to the top left, right? So pretty sure the commands is here, delete everything from the cursors, move the cursor to the upper left corner of the screen and clear the screen. So we want to have two of this, right? So let's just copy this. So we just have this print, and let's do a vi curly braces and copy it like that. And we're gonna copy what in here too. Alright, so let's copy this. Alright, cool. Now after we resetting the screen, we clear the screen, we reset the cursor to the top left, we want to print something, right? So let's print something like Minitop, kind of like that. Let's do a slash and so a Minitop. Maybe here we can say Control C to quit, right? And then maybe some dash here, right? So just like this. And after because we are running a program, this is not gonna appear in the terminal. It is gonna be in the program buffer, right? So that's why we want to flush it to our terminal. We want to flush it, right? So how we're gonna flush this? We're gonna first our SD out, and we're gonna delay. Oh, sorry. A delay for 1 second. And after that, we wanna unhide our cursor, right? Because we were hiding our cursor. So let's is pretty sure the command is like replacing L to H. So please copy this. Alright, so let's copy that and let's paste it here. We're gonna replace H with L with H, and now let's try it. So here, if we're gonna run mate, oh, there's an error. Implicit declaration of the function sleep. Maybe it is not exist or something like that. So pretty sure let's create a new here. Alright, so no, I'm not gonna be using this to create a new one. Alright, so here we can do a man's sleep. Missing error. library instead of the search for the C library. So this is the library, let's copy it and let's paste that. Let's go. Oh my god. You're here. Okay. Now let's try to run that. Alright. So let's go to our project. Here. See our Minitop. Alright, let's clear that. Now we can run make. Okay, it's worked. Now let's run Minitop. So you can see that we have an UI here. If we typing any word here, it's gonna be here, right? Let's do Control C to quit. To do 4J, let's go to the end that we're gonna add and enter here. Alright, let's try again. Alright, let's run make clean. Alright, let's run again our make. And let's run Minitop. Now our work gonna be typing here and each second is gonna be reset. Right? This is cool, so cool. Alright. That's good. Let's do Control C. And now we have our UI. What we want to do now is that, so if we can see in the top or at this top, it's kind of display all the information here, but we just want to make a simple version. Maybe I will want to display how many process is running, and maybe the uptime of our computer, right? And also maybe the low average here, right? So we're gonna display, probably gonna display this, our process that is running, right? And also our uptime of our computer, right? So let's do that. So let's see what we're gonna build next. So let's do uptime and low average, right? So if I remember right, let's do ls to our /pod directory and maybe somewhere uptime. Yes, it exists. So maybe I can do like a cat of it, drop to our uptime. So this is gonna be like this. Let's copy and try it. This is gonna be a second, pretty sure, and it's gonna be the idle time. So this is gonna be the seconds, which is 49,000 seconds. It's gonna be like 10 hour. I don't know. Yeah, more than 10 hour. It's like probably 14 hour or I'm not sure. Yeah, it's like, yeah, we can do an echo of this, right? Copy this. Let's just do this and divide by our second per hour. Yeah, it's gonna be 30 an hour. So yeah, we can do, let's do fast page, so we can see our my computer have been up for 30 an hour, which is crazy, I know. So yeah, we will gonna read the information from our prompt, right? And it's gonna write it in our buffer and then print it in our UI. That's what we're gonna do for the whole project. That's the logic, Alright, so in in order to display that, um, what we're gonna do, let me try to think. Um, so to well, we will first have to open the file, right? We have to open the file, and then we read the file. We read that lines into a buffer, and then we close the file. That's it. That's it. So here, this is our logic com. Just do slash slash. This is gonna be what? It's gonna be our uptime, right? So let's open the file. This is what we're gonna do. We're gonna open the file. Let's do app opens this from our prop slash uptimes here as read, right? I'm not really remember. Yeah, and if file is not exist, which is fail, we're gonna raise an error. Error gonna be file opens, right? And we're gonna return once, which is indicate that our program has failed. So so now after open the file, we can close it. Let's do app post this post the stream. So if you guys don't know what's f opens, I can show you guys what is it. So file opens, go to description. It's a functions that open the file whose name is the string pointed to by a path that we input, right, and associate string with it. So let's go to return. So what it's gonna return? It's gonna return if it's complete. It's gonna return a file pointer to that like a file description, like file descriptor. I mean, yeah. So it's gonna return a file pointer which is here, right? And yeah, like a stream. It's kind of open the stream, and yeah. And so we handle the error if it exists. Then we can do like if if like this, we're gonna like do create the uptime, and we're gonna use something to write it into that. Okay, we're gonna have this. Let's call it uptime. That's gonna be 0, and let's call it 0. So that also equal to 0. I'm gonna use something called fscanf. Pretty sure. Yes, sir. So it's from libc, from libc. Let's go to our description. So what it's gonna do, scan. So just read the input. Let's go here. We don't have fscanf. Alright, so fscanf is a function of C that is used to read the formatted input from a file stream, and it's gonna take the additional point that identify the machine which to read the data. It's a check point stream. Let's see what it's returned then. On success, this function returns the number of input items successfully matched or assigned, right? So let's call it. So we're gonna have an if clause, gonna fscanf a file. It's gonna read the format input from stream, and it's gonna write it into this. Pretty sure, right? Yeah, pretty sure it's gonna write into what we pass into here, pretty sure. Uh, yeah, this is the file. Oh yeah, so this is gonna be the format, right? Pretty sure, yeah. So how we wanna format? Look at this. Look at how this works. So if we do again cat of our prop to our uptime, we're gonna have two of this, right? So basically what we're gonna pass is a percent. Oh, um, a a mod and then LF and then space, no, and then mod and then LF. This means two floats. We're gonna write into this, but let me see if I add this zero first. That's gonna write to our uptime and it's gonna write to our idle total. And the thing is that this scanf f scan f that is gonna return to it's gonna return the number of items that successfully matched. That's why it's gonna be equal to 2, right? That's mean that it's success, right? So if it is success, we're gonna print f the uptime. So let's print the uptime. Gonna be a percent of f. Is that f? It's false f, right? I'm not pretty sure. Yeah, it's f, but we can do like one f, right? And we can do like the idle, right? Yeah, we can print the seconds, and then maybe a dash, right? And then idle, idle total. No, just idle, and we can have this one f2, and let's pass our uptime and our idle total here, and save it. And low-key we can move this on here, right? So if S, right? So L is gonna raise the error. So let's move this down here, and let's move all of, oh my bad, let's move all of this up here. So yeah, pretty sure if the error happens, we also want to close it here just to make sure. Alright, so let's try to clean first, and then we can run our Minitop. Look at this, look at how cool is this, bro. So this is up to date, right? Because the while loop is running, right? Every single 1 second is gonna update and flush this to the terminal. This is cool. Alright. So just add this slash f to this. Just make sure that it's look kind of cool. Alright, let's do Minitop again. Now the typer is down here. Oh yeah, it's look pretty good though. It's look pretty good. Or we can add some spacing here. Yeah, we can, and maybe a down slot there, kind of. So here, gonna add just like that, right? Yeah, it's look better, right? And let's add second to here, seconds. Now let's clean, and let's do make then or slap Minitop. Alright, it's look pretty good, bro. It look pretty good. Alright, cool. So now we have successful write the uptime and um, you know, right to our UI to our Minitop. What we want to do next is that maybe we can display the total process that is running on our PC, right? Oh yeah. Um, we are missing the load average. We wanna have that too. Let's do a cat slash prod uh, of our load average. So this load average is basically the process that is currently waiting for like to be processed. Pretty sure, I don't know, but we just want to display this tree just like top you can see this, they display this, right? This that is what we want to do. That's it. So let's go back here. So we gotta do basically the same things. We're gonna read the file, um, and we're gonna read that to a buffer, and then just print that, right? That's what we're gonna do. So it's like basically it's the same thing to this one, but for the load average here. I'm not gonna like organize the file in this real. Just want to code it real quick because it's pretty. It's gonna take a while. So let's implement this here. Yeah, just add this. So let's just open the file. Oh my gosh. Oh my gosh. This. Alright. Cool. Yeah, opens. Let's open our prop slash load average here as our read. So if f uh, so this is kind of different. It's not the same thing to up here because as we know, um, there's like pretty sure here there are like we want to take 3 of this, right? So yes, we want to take 3 of that. But yeah, let's make load once. Gonna be 0.0. Load 2. Wait, hold on. Is that? Yeah, it's a float number. So we pull. Just code this. Double load 3. Go to 0.0, and we're gonna read that, right? We want to read that using the same thing, our scanf. So f scanf to our f, and do this. It's also a float number, so to f, just like that. You can just take 3 of them and assign it to loads and loads 2 and load 3. Then this gonna return 3, right? So, yeah, pretty sure, bro. If it's return 3, which is success, then we're just gonna print load average, that is percent of f a space 90% 1.f the space 1.f, and then pass in load 2 and load 3 just like that, and we're gonna have error handling. If it fails, we're gonna raise an error of probably F opens, or maybe it could be this, I don't know. No, it's gonna be error out here, right? Gonna raise the error of F opens, and we're gonna return 1. Definitions, is that cool? We can redefinition that? Yeah, pretty sure we can. So let's delete this. Alright, so let's make clean. And let's make this and run our Minitop. So yeah, I'm pretty sure this our load average is currently displayed correctly. If I pretty sure, let's do a top, and yeah, let's name this out so we can see it pretty. Yeah, we can have a float number like maybe 2F. 2F here would be better. Yeah, kind of zoom this out. Alright, let's quit this. Alright, so let's do channels to 2. Alright, so let's make clean and just make again and call out Minitop. So yeah, we have our 2 float number here. It's pretty cool. And the slash n, of course. To enter the lines. So now we're done with our load average. What we're gonna do next is we're gonna display the total process that is running on our computer. So this is what we're gonna do. If I do a cat to, no, let's do an ls that I already did here to prop. So this is not process that is running like all of this. This is system wide processes, and what we're gonna want to worry worry about is this number tag folder. Each of this is a process, and a program can have many processes running at the same time. So we just want to count all of the process ID. If this is a number, if like this number, then I mean we just count, right? So um, so the thing is that we're gonna use here. Let's do here, and let's call process process counts, right? Now what we're gonna use here is we're gonna use open directory, pretty sure. Let's go man open directory. It's from libc. The library is gonna be this. Let's copy it. I don't know if we can copy. Oh, yeah, we can. Okay. Let's copy. Now, yeah, before going back, we want to see what is this, right? So descriptions. The open dir function open a directory stream corresponding to the directory name, return a pointer to the directory stream. So this means that the return value, wait, hold on. The pointer Oh my god. Yeah, pointed to our directory. Pretty sure. So it's gonna be like this. D. I can call this D, pretty sure. Or I can open directory and let's open our prod dash um 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 counts, right? Yeah, just this, right? You just want to open our proc directory and read it, right? So what we want to do here is that just check if it's success, right? Um, and also um, we want to have a pointer because how can I explain this? Just go to read. No, I'm gonna explain this. I don't know if anyone is watching this, so I have to explain. If you guys watching, like people don't even watch this video. But so if we call this open directory, this pointer gonna point to the stream of that directory, and then we will have this functions, which is read directory, that's gonna loop over the next and the next entry of the directory. That is this gonna return a struct that is direct. So that's why we need a struct direct pointer. This pointer, right? And so we're gonna have a while. It's gonna happen. ent this will be equal to our pointer of this. That's gonna loop over our directory, right? That no. Like if it's gonna keep looping until it is null, because if we do a read directory, so return. Okay, so it's gonna return null at the end of the stream. So this is why we have a null here. That is indicate that we have reached the end, that we're gonna stop looping, right? So we're gonna have some logic that we wanna compare, like we wanna see before. I just wanna go up. So here is what I was talking about. Here, go down. So this return a pointer that point to a direct struct. So the direct struct contain some of these, but we only worry about this the name, which is the name of the process, which is the PID, which is the process ID, right? So yeah, we just have to worry about that, and we want to have a logic to you know to compare, like to check if that is a number. Let's call the function is number here before we implement it. This is gonna point to our D name, right? I'll show you. So if this is legit, right? We're gonna do account plus one, right? So let's do here integer process count equal to 0 here. So let's do that, and we want to have our process count increased by 1, right? Let's do this, right? And we want to declare our functions. Is this a problem, bro? I do not think it's a problem. Oh yeah, here, like that. So let's declare our functions up here. This is gonna be check number, right? Check is number, whatever. So we're gonna define this check number function is gonna return an integer. It's gonna be like yes or no, 1, 0, 1s, right? It's gonna return a boolean or whatever. But yeah, it's better if we pass in char, so it's gonna be a char that is the pointer to this if, you know. So yeah, if not the s, right, or not, we're gonna destructure our s, we're gonna return 0, which is false, right? And we're gonna do it for this loop till if our the value of our s is not the ternary this, right? S plus plus. We're gonna do if is digit of our s here. We're gonna return 0 at the same too, right? At the end, this means that the whole string is a number. Then we're gonna return 1, which is true. So here, this gonna legit, right? Then we can print it after this. Let's do a handling error before that. Just gonna call this open directory, and we're gonna close our action. No, it's gonna close it anyway. So maybe we don't. Yeah, we don't need this at all. If we're not returning anything, why do we need to return it, right? Yeah, we might need that. I don't know. I mean, it's gonna crash the whole functions, but I mean, we do not need to return 1 here, pretty sure. But yes, we do not need to do that. And here, when we open our file, right, we also want to close it. Maybe we don't need to check for this logic low-key. And we want to close this here, right? The same things for this one is after it opens, we want to close it. If it's failed, we still want to close it, right? So let's close that. Just close our app screen here, and then we're gonna print here. Let's print. Let's say this is a total counts. No, let's say it's total processes. Gonna be a digit, set n, and process count. Perfect. Now let's try it. Let's do make clean and make and oh, call to post is here. In our 53 and 65. Let's go to 65. Is that a problem? No, we want to close our directory, right? No, let's close our directory. Gotta be uh close directory. This. Uh-huh. And 50, 53 here. What's the error here? Maybe we don't list this. It's not gonna fail, low-key. So just to make this work. So there are currently 393 process running. Cool. Wait, hold on. Let me check my discard. Resistor saying. It's like a text editor, but it's read far from procs to process the system info. Let's keep doing this. Um, so yeah, we have our process. That's just straight. We have everything's cool. So now what we want to do is we want to display um like all of the our process ID here, and like then it's gonna be like names here, or maybe memory usage, and then RSS, like this way it's in the column like this here, right? So yeah, this is what we're gonna do. So we're gonna loop over the process ID, and we're gonna read of that, low key for. We're gonna read the process ID at the same time to display that. Yeah. So we're gonna do a open directory, loop over everything. For every single loop, we will track the process ID, and we're gonna like format the string to create a new path for that specific, slash proc and then slash one or a number, which is the process ID, and then slash stat, and then access it. So in our stat, it's gonna be like a one-line format that inside that there will be like, let me show you. So here's what we're gonna do. We do ls.proc. So we're gonna access this right, and just for example, this we're gonna pass this into format its path, and then a stat, right? Then we're gonna access this using strchar. We can get the parentheses, and then we can do something to get this into a buffer, and then just display that. That's it, right? Okay, so that's what we're gonna do here. Just go back to our code. Um, so yeah, we want to have functions. It's gonna be a pretty bad function, bro. It's pretty long. So let's do. Just gonna name read PID, process ID, and process name. Yeah, that's what we do. It's gonna return, 1 or 0 only, which is this. Read PID. This is called read PID. A const char that we're gonna pass in the PID as the string, and then a char of the buffer we want to, the names, and then the size, because there might be some process that is having like a long ass name, but like we just want to display like just a certain name so it's can fit in our columns. So that's why we want to have a size t of size here. Yeah, that's why we're having it. Just do a char path of like this. Just move my mouse here. We're gonna have aspirin. If you don't know what's aspirin, let me show you what is it. So aspirin is basically it's gonna write into the buffer. So here the S and aspirin is right at both sides bytes. So it's gonna write a certain byte that we want into a string, like into a buffer that we want to. So what we're gonna pass in here will be our path, right? We wanna write our path, then it's gonna, the size of our path, because it's a fixed path that we're gonna like format our path. Let's say this is a string here, right? Which is the process ID, and this is gonna be the sat as I mentioned. Gonna pass in the PID here, and nope, that's it. The fuck, PID, yeah, that's it. And so we're gonna have that string. Then we can open the file with the path that we just formatted as read. So now we have successfully opened a specific stat of a process, right? What we want to do here is we're gonna find that specific name inside the parentheses. Remember, we're gonna find it and then write it into this char name, right? This will be automatically write to the real buffer because we are passing the address into this, so this is being passed as a pointer, right? It's not that hard, right? So let's do this to f. So if f is not exist, we just fail. We return -1. Then we can have a buffer. Let's give it a big number. And here, because we're gonna read the whole lines before we parsing the lines, you know what I'm saying, right? So we're gonna use something called fguess here. Let's pass our buff in, our size stuff, the buff that we restricted, and it's gonna be the stream of 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 it, you know, and we want to close it right after we open this because there's nothing to do. I will show you what is F gets. Wait, are there any around here? Yes, there's here S instrument. Alright, cool. Student of F get S. So this gonna read the next character from the stream and return it as an unsigned char cast into an integer. Oh no, that's why it's weird. Yeah, this is correct. This one is the one. It's gonna read at most one less size character from the stream and store them into the buffer point 2 by s, which means it's gonna read the lines in our stat file and then it's gonna store this into the buffer. That's it, right? So that's why after this we can immediately close this, right? So yeah, let me see. If this fail, we're gonna close it. But if it's not fail, we still wanna close it, right? But yeah, we're gonna do some logic here. If it's not fail, so we're gonna find our left parentheses by doing a string char, SCR char that we're gonna find it in our buffer. That we're gonna find our open parentheses. I'm pretty sure we should do this. It's better. I don't know. Yes. Yes, look at this. SCR top. Oh my god, I can't speak anymore. My throat's so hurt. Does not exist? What the fuck? I mean, you guys can search it yourself, bro. I'll show anything. It's gonna take so long. But yeah, it's gonna like give you the memory address of the first occurrence of what we want to find here. See, it's pointed to the first matching character. So yeah, this is what we're gonna do. So char right into this is gonna point to the last occurrence of what we want to find here. It's gonna be the close here. Let's point to the last occurrence of that, and we'll say if not left or if not right, right? If not left, if not right. Yes. If not left or if not right, or if right is smaller than left, which is absurd, which is we return negative ones. Return negative ones here, and we're gonna have our size t. We're gonna size of the bytes. Length's gotta be, you know, right. Subtract 4 left and subtract 1. What we want, right? And we want to if the length is higher than or equal to the size. As I mentioned, if the name of the process is too long, we're not gonna give a fuck to it. We're gonna skip it, right? So just make the length equal to the size, subtract for 1. Just make sure that we have a place for a determinator, right? So let's copy it, right? Let's just do a copy. There's a copy here to our names. Let's do that plus 1. Let's do length. I'm gonna explain, right? Well, not then the last one of our name, this is equal to our terminator, right? And we're gonna return success. Okay, so what we're gonna do here? What's this shit mean? So I'm gonna write something like this. Let's say Firefox. So this is an example. If so, this gonna point to here. Oh, this. Oh, where's it? What the fuck? Oh, okay. So this line gonna point to here. This parenthesis, and this shit gonna point to this parenthesis, that including this and including this. So the thing is that we only want this, right? We only want this. If we doing right, subtract for la, there's still here, it's still considering this bytes, so that's why we still need to do another subtract for ones. And yeah, if the length is exceed the size, then we gotta string the length just to size subtract for ones, and we're gonna copy this into our names here. And that's pretty much it, right? We want to copy from this to this to in our name, right? So that's it. Oh, what the fuck? Oh yeah, should delete this. Okay. So now we can do a loop in our main functions, and we can display it just right? Let's see. Let's come. Split loads process count here. Let's do a/lab process and our name, right? This is what we're gonna print here. It's gonna print a pit and a name, right? Before it's print like the actual value below. So let's do /n a pit, and we're just gonna do some space, like let's do 1 2 3 4 5 6 7. And then you can change this later, so it doesn't matter. Doesn't really matter. Let's do a open directory to /5, right? And no, this directory we're gonna have a struct. I'm not gonna go over this again, as I already go over already. Oh shit. Okay. So while ent, if you go to read this directory, it's not null, right? It's not null. Let's delete this. What the fuck is that? Oh, read directory is not null itself. So yeah, we still want to have this. You sure? Nope. Like that. Over like this. We don't even need that. It's gonna just reassigning that to the pointer. So yeah, like this. And maybe we have shown what is what we want to show. Maybe just, you know, 5 or something. So it's equal to 5. Maybe, yeah. Let's initialize show here that, you know, show equal to 5. No, 0. And so let slow shown is cannot reach 5. We just want to show 5 process, and we're gonna print this. No, we did not. We just have like this. So we want to check is number of our ent d name, right? So if it is not number, just continue, right? If yes, we're gonna create a buffer, a name buffer is this, and gonna read pit here and pass in our pit, which is ent the name, and this is gonna be our name, and this is gonna be our size of our name, right? Why there are existing this slash of that? Okay. Then we're gonna print this percent mod 7s. We want it to have a space of 7 indents, and this as slash and just that's is now, and our ent the name and our name, and for each time we did this we just pass shown by ones. Oh, oh yeah, so we need one more. Three definitions, we opened this before, so maybe we do not need to reopen it again. Redefinition there. We opened this before for our cam, our plot cam. So down here, we are not gonna open that again. But why would we want to open that again? Right. We have our bit on here. Nope. Okay, this is kind of weird. Yeah, maybe this is good already, and we want to close our after all of this. Yes, we want to close it here. Let's close our directory, and just gonna try it. Clean 8 slash Minitop. Okay, pretty sure there's an error that there's nothing show here. Right. There's nothing show here. So there's an error. Just debug this. This turn right into our path. Beside of our path is gonna be the string of the pit. And then we're gonna open this as root. And just return to the front. Okay. If not yet buffer, side of buff, and passing this buff. Pretty good. We're gonna close this anyway. Start char buffer. Fine for us. If not L or R it's smaller or equal to return out of ones. Okay, this is incorrect. There's no way this wrong here. Our nameline is gonna be terminated. This is gonna be our name. L plus ones. And L lines. Return. Wow, out of ones. Uptime either. It's uptime and either. This is just fine because this were working, right? Previously it's were working. No. We pass the name and it's gonna decay, which is just fine. We go to our open directory. I'll close our directory here. SD out. Fuck it, bro. What is happening here? Integer strings. Remove showing 0. It's gonna be different. Let's start space the process. What could be if I hide this and then, initialize this with our directory? Yeah, it's not a problem. I think it's not a problem. Maybe we have any syntax here. Hmm. Alright, bro. Fuck it, bro. Oh my goodness, bro. Alright, it's work, it's work. God bless me. This, no, it's kind of indemnized into kind of far away. Right? It's kind of far away. So the problem is, this function, returns 0 as its success, but if we not, like, compare it explicitly to 0, it's not gonna write because it is expected true, but not. We are returning an integer, so that's why. That's why it's fucked up, bro. It seemed pretty good. It seemed pretty good. We can display more, right? Let's set 5 to maybe 15. Because why not? Right. Yeah. Why should? Yeah. Yeah. This is good, bro. It's good. It's good. Alright. So what we're gonna make next is we're gonna have RSS. So RSS is essentially to be here if we do a cat to our graph or to our status. Be sure status like this. It's not existent. How about stat? Not this one. If we go here, let's go. No, I just closed it. Processing. Let's find our VSR VM, yeah, VMRSS. This is the one. So this is a side memory. It's basically the physical RAM being used, and that's it. It's nothing more than that. So what we wanna do is that. That's my cursor, bro. Cursor is just here. So yeah, we wanna have what call it RSS here as a columns that is display the RAM, like the RAM usage of the processes. So this is what we're gonna do. So yeah, let's go to let's do let's do it. But the thing is, we wanna know where this at. VRS in our sub status. Okay. So if we do a vim, no, if we do a cat props once dash status, it's gonna be here, yeah. So it's gonna be there. So basically, we just pretty much we gotta do the same thing, mapping it, you know. We gotta display it. So we're gonna have another functions that we're gonna add RLS here, having that function to write in our RLS variable that we can display for each of the processes. Yeah, that's it. That's the idea here. Let's implement it. So let's call this, you know, RLS. So let's call it integer read RLS kilobytes. This is a cons of character bit. it's gonna be a long RAS because it's gonna be like a 100,000 of kilobytes, so that's why we use so long. It's gonna be pretty big. We're having a path up to 36, 56, and we have our SN frames. Our path sides out our path, and this is the path that we want the prop to be. We already know, right? What's the thing? S slash status, right? Oh my god, my eyes hurt. It's gonna be pit, and that's it. It's gonna write into our pit. Now we can access our path, right? Guys, opens. No. It is path opens. It's gonna be path into as read. That's it. If F is failed, we're gonna return F1. If it's good, we have a trial lines of this, while F gets is our F gets of our lines gonna be sides of our lines. This gonna read to F, right? So then if SDR of our lines, if you don't know what is this, let me explain. So this is gonna find the first occurrence of the substring, which means the fuck was that? Let's do a cat of this status. So it's gonna read this, and it's gonna find where it's have the first occurrence of this. So BMRSS double colons a semicolon. I mean, yeah, that is gonna return something. And let's see, return slash return. That is gonna return a pointer to the beginnings of the located substring, or no, its substring is not found. So if this is going to the lines, because we might have many lines, right? We're gonna have many lines because this F gets gonna read lines by lines of the stream. So so if is the case, that line is the case, we're gonna scan through it. So what is scan F? I think that we have had this before. This one read their input from the string pointed by SCR. That let me see. Scan the format. So basically, it's just gonna scan, like it's gonna scan through it, and then it's gonna reformat the string like that. That's it. So you could pass in VMRSS. This would be L a digit. That kilobyte, right? Pretty sure it's kilobytes. And then we're gonna pass in our RSS. Did we have that before? No, we didn't. Oh yeah, we have that on that. There's kilobytes. Where's our RSS kilobytes? Yeah, we gotta pass in here. So it's gonna write this into this, right? It's gonna read to this, read through lines, this gonna extract that extract that line in this whole fucking file, and gonna write this into the RSKB, and also format it while writing it into this, right? And it's gonna return search for return. It's gonna return the number of items successfully matched, which is just one, right? So it's gonna return, then we're gonna close it. We're gonna close our file, and we're gonna return 0. We have call to unequal site up. Oh, right. And it's gonna have close here. If it's a success, we go close it. So this is set. We're gonna return 0. And if not sure, like out here, we're gonna also return close it and return negative once. Like if it can't find that, it means can't find. But I mean, it should be able to find our this, right? Able to find that. So now we can use our function in our main. This here. Process. Now shown. We can combine it with this functions. Call it as am. I'm gonna pass in a function, and just call it with just kilobytes. You know, this will be the name, and this gonna be the RSS. This create this long RSS here, right? Yeah, and then just want to display it here to be, this gonna be a long string, so let's do this and percentage LD slash n, just like that. Incompatible integer, what the fuck is that, bro? Oh yeah, we're gonna pass in the address instead. Let's format that our F here, something around that, have that. Oh no. Let me count this. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5. This, gonna write it here, RSS with kilobytes. And let's save what we changed. Now let's run again. Make, oops. It's a long digit, so format expect a matching long integer. What you mean, Matt? Long digit. Aren't it a long digit, bro? Like a long. It's a long, but oh yeah, pass in here, bro. Alright, cool. Do make and dash that. Call this. Yeah, so it's worked, right? Because I mean, it's kind of small, so like it's not even used that if see the like if I do like this cat slash slash 2 slash status. It doesn't even, is that status? This doesn't even have it, bro. This doesn't even have it. Know why, but yeah, it doesn't even have it. And this kind of suck. We should have a limited outside already. Like the name gonna be. Should we limit this? Not really. Just kind of space everything. Like how can we have a nice spacing here? Just do that 15, something like that. Limit application. Okay. 1, 2, 3, 4, 5. Well, this is a dead ass long name, bro. Maybe we might need to slice it. Just 10. And this, leave it like that. Okay. Yeah, just leave it like that first, low key. Oh, gee. So now we have our RSS. What we want next is our memory. I think this is the biggest shit that we're gonna make. It's gonna be the memory usage, and yeah. I think we should start to code it before, and I like if we meet anything that is new, I'll go over it. So just defines the max process that we want to this, like our array to store. Let's have this. Let's have this, and we're gonna have a type def of struct that is pitch name gonna be 06. It's gonna have a process ID name, a long. This is what we have already. Unsigned long bar text equal to this, and unsigned long a ref I'm gonna explain this later. We have a double CPU percent like that. We're gonna name this something for informations. Okay, so this is the formula that I found, like how to calculate the memory usage. It's here. We have the U time and the S time. This will be in the stat, like No, let me show you. Do stop this. Do a cat. That one. That step. It's somewhere here. It is somewhere here. The U time and the S time. We're gonna plus it, and then we're gonna divide it by the CPU's usage, which is pretty sure it's in here. Let me see. Proc stat. And no. Stats. The sum of this first line, the sum of everything gonna be the total CPU usage. So we're gonna divide that, and that's it. So yeah, just go over quick. It's already a pretty long. How long is that already? I can't tell. Yeah, an hour. 2 hour. So yeah, we're gonna have functions. So this function's gonna calculate the total memory usage of the CPU. So let's name it here. CPU sum, something like that, right? Say total CPU. This is better. Alright, let's read total CPU text. That we're gonna check in unsigned long wrong, right? Of our it's gonna be total. We can name it whatever. It doesn't really matter. And then we're gonna open the file that we're gonna open what I already mentioned. That is gonna be the part and what is it? The part and stat, right? The part and stat as read, right? If this fail, then we're gonna have some. We're just gonna return -1, right? Then we have a child lines out 1, 2. That if get is line is the side of our line, lines, and it's gonna read F. So let's go post it and return negative. Return negative once. So now our lines will contain like just the first line. We just gonna read the first line, and then we just calculate the sum of it. So let me show you. So yeah, we're just gonna read this first line, and we're gonna get each of this, and then sum all of them. That's what we're gonna do. So let's go here. This one is stat of it. CPU. Let's find it. Pretty sure it's no. We going so far away that is not. Let's find stat here. Yeah, so this line is essentially user niche system idle of this for the first line, right? As we're gonna parse it, and so let's do it. Before we even do anything, let's close this, bro. And so we're gonna create unsigned long. It's gonna be, user. Let's bring this into the first workspace so we can see it's user. Where is it? let's try this. Okay. User, nice, systems, ditto, I'll wait. IRQ, stop IRQ, still, yes, yes, nice. Alright, then we're gonna have integer, but let's go back here and go to a scanf. Gonna scan the whole lines. This is what we wanna format it. We will format everything into this long, just long unsigned long. We might have to count this and then double it. It's just that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So it's gonna be 10. So let's copy this and paste that. Nope, I copy this. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's enough. Then I'm gonna pass all of this inside, right? So let's go with user, then nice, then systems, it'll, I'll wait, IRQ, soft, IQR. Is this correct? IRQ. Okay. It's IRQ. IRQ. Still. Yes. Right. And. Oh my gosh. Yes, nice. Alright. So. So if n is smaller than 4, then it's gonna give a fuck to it. Return 4, bro. We're gonna have unsigned long our sum equal to 0. So compare if n is higher equal to 1 and sum gonna plus equal to our user if and you know, let's just copy this. Alright, so copy that. Plus F1 to, you know, this is gonna be nice, right? Yes, sure. Alright. It's gonna be a system. Wait for, oh my god, my hand is shaking. Dito, store 1, 5, FU. Oh wait, alright. 6, go chain 7, 8, 9, and chain. Oh shit. Let's do FU, CIW, CIRQ. This is gonna be soft, IRQ, still, right? Guess, nice. Oh. Save it. So we have this. So we're gonna have total but equal to our sums and just return 0. So yeah, we have successfully, this is the functions that we're gonna calculate the sums of the memory. No, I mean the CPU memory. So now we will have a function to read like the U time and the S time of each process. It's gonna be a while, bro. So yeah, let's do it, bro. Let's name this read process take, like that. Read project. That's gonna take in const char pit unsigned long gonna be the text. Alright. The text. Yeah, like the value that the questions. And set out a path of this assembling that sides up our path, and this essentially be super dash shepherd slash divide s stat and bit, and open a file that's gonna be opens to our path as read. So if it's fail, we're gonna return negative ones. Create a buffer 0.96. Alright, we have f. Now f gets passing the buffer inside out the buffer. So it's gonna be f, and it's gonna close it. We just wanna, it's only one line, and we're gonna get that line, just one line. Right now, oh my god, where's the pointer? Alright, so let's call these range. That'll be s char of our buffer. So we just we go back to our, we will find the last like the last appearance, like the last occurrence of the close parenthesis. So therefore we can skip over, you know. Let me show you. So we're gonna skip over this. We will start from here, and as I pretty sure we'll start somewhere here, like yeah, it's gonna start from here. It's gonna skip this and this, right? We're gonna skip this and this. We're gonna start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So the 12 and 13 gonna be the U time and the U time, which is somewhere here, as I mentioned. So just go here. If not random, let's return the other one. And we have our char on like ranks +2. Right. We have our char shades unsigned one. In due time, set it to 0, and can we do this last time? Let's set it to 0 too. Don't know if we really need that key. Okay, so here we're gonna do this in. Okay, gonna be scan of this first line. Go start from here. The reason we +2 is that we start from here, and we gotta jump to like start here. That's why. So let's move here. Let's delete that and move down here. So okay. We don't really care about this because we just take the 14, the 12, and the 13. So let's just structure this into something randomly. Just 1, 2, right? Let's copy this. 1, 2, right? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. But it's 11. There's something that it is like not always. This can be long or something like that. Just make sure. So it's gonna be 1, 2, 1, 2, 3, 4, 5, 6, 6, right? 1, 2, 3, 4, 5, and then 6, and 2, 7. It's gonna be U, U, U. All of these gonna be LU, pretty sure. And the last 2 is gonna be so the last 2 gonna be LLU, which is the one we want. Unsigned long. Just want to count these ones again, just to make sure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Cool. So just want to pass 2 things in, which is due time and S time, and that's it. So if OK is not 2, we return -1, and we have ticked gotta be equal to U time plus S time, and return 0. Okay, it's pretty good. Now we're creating a struct. This struct gonna be like represent the previous pit struct. Why we need a previous pit? We need the previous pit because we have to calculate the memory usage, and the memory usage require the previous ones. We need the previous the previous tick and the previous CPU memory that we do a subtraction before a divisions. Yeah, let's do this. Unsigned long previous ticks. Let's call this previous tick like that, and let's call this previous entry, something like that. And the last function gonna be find previous see ticks, but find let's find previous, gonna pass in our first entry, and it's gonna be our plastics. No, it's gonna be our previous and count. And just do a for loop of our count. That is if try dot pip is equal to, you know, pip dot pip. Yes, I'm gonna return that, the value of it. Return the index. I was gonna return the font as well. So what this will do is we're gonna give these functions the previous counts, the previous struct, and the pip, and it will loop over the old, like the pip or the previous array, like the array that store like all of the previous pip, and it's gonna wrap up like whatever where that the pip equal to the pip, like the position where the pip is equal to each other. Then it's gonna return the old index. That's what we're gonna do. You'll be more understand like when I code this. Yeah, pretty sure. So in a while loop, look, you want to hide this, like not always, but just hide this one here, and then just put entry, just put entry max up that we had created here. Enter our previous count, initialize it to 0. Unsigned long previous text gonna be no, Loki total equal to 0. This is gonna be the total CPU usage of the previous state. So let's read total CPU text. I'm gonna pass in our track total, just like that. So let's say value, unsigned long of the total now equal to 0. If read total CPU text total now is not 0, which is fail, we're gonna fall back this. So we set this equal to the previous total as well. Unsigned long let's call this the delta total. Gonna be equal to, you know, total total now, if it's higher equal to the previous total, right? If it is thus, then you just get the total subtract the previous. This is the subtraction of the total usage. So we have the delta. So pretty sure we have the delta. Fuck it. So let's check the message later. Oh, this. So just keep initialize this and sign long. Let me really read that. If I can print this for now. Yes, we enough. Unsigned. And we're gonna print everything like that. Print. Oh, yeah, this is pretty cool. The process count. We can go to this. And this gonna be changed a little bit. Total processors into this. Here gonna be changed a little bit. Just go to the last that now we have the name. Thus the name pretty long, so let display the name at last. This will be better. 2%. You know, 2. We can do like 1, 2, 3, 4, 5. Let's do 2. 1, 2, 3, 4, 5. Maybe 6. Okay. It's 6 like that. 1, 2, 3, 4, 5, 6. And it's gonna be our name right here. Alright, this is cool. So we have our pro info. Create a prox list that is here. And account for all the process we display so far. Just gonna keep the same here. This okay, this kinda need to be changed. So let's FS here. This is to pick counts and max bars. Okay, so if this is here, we're gonna continue and create a pit object. int.2 the name. We convert the name from to from character to into integer, then we create this for info of an object p and a method set it's all to 0. Just pass this inside. Okay, that's size up pi, you know. We can do dot pit equal to pit. Just like that. And if we pit lucky, this is what we do. Let's delete this into pit if now we're gonna check. No, if read pit that the pattern bnt dash the name. This is gonna be just the name, the name, size of, you know, p dot name. So if it is 0, we kind of want to continue, and we have functions of RSS. This is what we're going to pass in. Dot. Alright, if it is also 0, nope, we're gonna continue for this one. Or maybe we can set it to 0. Right? Set it to 0. Yeah. If we now we're gonna read prop text, assign it to our p object, the name, and here p dot prop text, different to 0. Then gonna continue there, just like that. And we're gonna have an int of, and that's gonna find the previous that we're gonna pass in this the previous, and then previous count that we already have, and here. So now we're gonna have the index. Human toy ID standard library.h. Include that. Standard library.h. Okay, let's go back. Right. We will do this. So yeah, I'm gonna pass in the list for that, and it's gonna find. Now we're gonna already have the index of, the previous, like the index of the current process that we are processing, but it's in the previous, the old, the memory, the old array. So if it is higher than equal to 0, which means that it exists, right? So we do pref progress take, gonna set it to the previous, index, right? Dot previous take, right? If it's not, which means that this can be the first one, like it's not existed in like the previous one. So we set it to the proctor the pi dot just proctor like that, just like that. Okay, gonna create unsigned long delta. This delta procs equal to pi dot proctic, right? If it is higher or than equal to our previous proctic, right? If it's due, right, we're gonna do subtractions between the proctic, do subtractions for previous, right? Else maybe 0, right? Yeah. So if our delta proc it's more than 0, then we're gonna assign it to our CPU percent. It's equal to 100% time our double converted of our delta proc, right? Divide by the total. Delta total. Just like that. Else y dot CPU percent equal to t or 0. Just like that. Now we're gonna have proc count plus. Before we go into the next one, we're gonna assign it to pi. Then we're gonna plus count for 1, right? So we're gonna have delete this. Now we're gonna have set ref count back to 0. We're gonna have a loop of int equal to 0, I smaller than count, and if the previous count is smaller than the max proc, and just do I plus plus. Do that I plus plus, and get the previous count dot pit. Assign it to the current pit. The current I. We are looping over if it's like this. Yes, at the same time, go just append it like that, right? That previous ticket proc I dot proc tick is what we have, and we just do press count plus, and we have graph total equal to total now, and finally you can display as we want. It's smaller than 0, 10, or it can be 15. It's gonna be count. Else it's gonna be 15. And another loop. Smaller than shown by blah. The percentage at 70%, 5.1f, 8, LD and ES slash N like that. Charts I dot dot CPU percent, and then CS RSS, right? Dot RSS kilobytes, and so that's gonna be the name. I dot name. Right. Function and let's test it. Oh my gosh. Okay, we might have some error because we have many error. Passing arguments. Take the address with this because we need the address. 176. Yeah. Int 2 3 5. Integers. No, we don't have this. Alright, so make this LLU. Long unsigned integer. This in our functions. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe we need something A4 for sidecar. So maybe we need a state here. State. Yeah, we might need that. No. Address. What? Right, bro. Fuck it. What? Use that sun instruction that line of function everything. If you mean the is wrong here? What is wrong here? That is in yeah, maybe because of this. Yeah, sure. So yeah. Oh, wait. Sure, can make that. Oh, no, we have AI find error formula. Let's copy this. We make thing. Alright, it's working. Let's turn this off. It's look pretty good, right? Yeah, it's look pretty good to be honest, bro. Look, it's look pretty awesome. Now we only need to short this because this is like the process based on like the order. We just want to short it and it'll be cool. But before that, I just want to see if we kind of need this kind of space, you know what I'm saying? Uh, let's find out this space with this. Okay, FD. When these right here, say 1, 2, 3, 4, 5. Let's save it. Make and then wait for this. 1, 2, 3. 1, 2, 3, 4. Let's just wait this. Okay, name is like 2. Okay, 1, 2. Make one more. Alright, it's look good. It's look pretty good. Yeah, I pretty like it. I pretty like it. So now, what we want to do is just sort. That's it. After we sort, we gotta sort like by the memory usage. So CPU usage, you know, so it's gonna appear like top to it. That's it. Gotta use Q short. Sort before it's gonna implement this. This convolutes of A and A convolute of B that we're gonna pass in here, and we're gonna cast this into a pros infos string this reciprocals info. For info down here, so let's paste this here. Alright, so we're gonna cast this, right? Because this void a void pointer cast, so we one on B. So if party of this to this CPU percent, it's smaller, it's higher than P1 to our CPU percent. We're gonna return 1 because for our Q sort, if this functions which is smaller than 0 it's not gonna swap, so that's why we need it to be higher than 1 because higher than 0 because we want to swap it, right? This is higher than that, and because we want it to be like in a descending order, which means that the higher the memory, the CPU percent, the top is gonna be right. So if this is smaller than this CPU percent, we return 1. Else, which means it's equal, just return 0. So it's gonna keep, you know what I'm saying? Just like that. Alright, cool. This looks pretty good. Now we just want to Q sort applied it CMP CPU December before we rendering this right here. We wanna do a Q sort. Oh no, yes, the base gotta be uh, the props, right? This size of it's gonna be size of what? This is gonna be size of what we're gonna pass in, and the size of the limits. The size of what the fuck is this, bro? NMB is the size of the array, right? This is gonna be the size of the struct. So this for info does the struct includes and our function cmp. Bro, what? Just delete this cmp. Let's code that. Let's do c8 this. Don't want that. Oh, sorry. This is what we have, and pretty sure it's gonna work. Let's try it. Look at this, bro. Look at this, bro. Look at this. This is yes, so we done, bro. Look at this. This worked perfect, bro. OBS is taking 4.9%. The other, Discord, my terminal, Novum, Tmux. Perfect. This is perfect. Alright, see you in the next video. Bye, bro. Bye.